Welcome everyone to TAM Lab number 42. Today we're excited to have Rahul Stephen joining us all the way from Singapore, who is a senior technical account manager, and he's going to be going through a high-level HCX Enterprise overview and jump into a demo environment and where we'll be able to kind of see how it works and ask lots of questions. So we're excited to have him here. And with that, I'm going to stop sharing and I will hand it over to Rahul.
Awesome. So you guys can see the screen that I'm sharing, right?
Yep, looks good.
All right, awesome. So we'll get started. So firstly, thank you guys for joining in today's call. And my name is Rahul Stephen. I'm based out of Singapore. I've been at TAM for roughly about 3 years, primarily focused on FSIs. So a lot of my customers are banks and financial investment sort of corporations. So I wanted to talk about the subject and the topic of HCX for a couple of reasons. Firstly, I think it's a very cool technology. It's in a way sort of unparalleled in what a lot of other cloud providers offer in terms of their cloud adoption. And secondly, I've seen this solution in action. So the way that I intend to run this presentation is in the chunks of 20 minutes in 3 chunks. So the very first one would be what are the use cases, what are the features that HCX provides. Then I want to also walk you through a demo. It's a pre-prepared demo, so you will have access to that as well, just in case you would want to share it with your customers or you want to showcase it. You can grab the link and run them through as well. And finally, I would come back again to the slides and share the customer success story that we had in the local region, how they consumed HCX for a very common use case that we see, and what are the benefits that they achieve out of it. So again, I'm not from the BU. If there is anybody on the call who's from the BU or from HCX engineering, please chime in, keep me honest. If you think there's something that I have not taken into account or it's a very recent development, please keep me honest. So just to give you a background, HCX a product starts with a vision of providing hybridity to the workloads. So the vision for this product is, as long as the customer is using the hypervisor as vSphere, then they should have the ability to migrate that workload wherever it makes business sense. So let's say there is an application that wants to consume something which is native to AWS, then VMC makes a very good business sense to host those workloads in VMC. Let's say there is no VMC, then VCPP providers are there. The solution can help customer move from their on-prem to one of the VCPP provider clouds. On the other hand, let's say the customer has 3-4 data centers and they find that one data center, it is cheaper to run more workloads. In that sense, they could migrate the workload wherever it seems makes more economic sense. So again, the genesis of this product is actually based out of SoftLayer and vCloud Air. The product was actually made available, generally made available to customers roughly about 2 years back. It was for a period of time also called NSX Hybrid Connect. I'm not sure if that name still sticks around. But it's 2 years ago that it first started coming on the horizon for general customers. But it has been there on IBM SoftLayer and vCloud Air on for a number of years before it was made publicly available. So this is the high-level vision of what HCX tries to do. What are the use cases that it tries to address? Well, the ones on the left are pretty closely knit together. And again, as I mentioned earlier, the customer success story that I'll be sharing towards the end of the slides, it's actually a data center modernization. So the customer was moving from a legacy hardware, physical network, and a traditional storage sort of an environment to a new data center, which was fully on HCI, fully on NSX, and running the latest and the greatest version of vSphere and related software stack. So data center modernization, data center extension, consolidation, potentially DC evacuation as well. So these are more catered towards on-prem to on-prem sort of migration, could also be used from on-prem to cloud. On the right side, the very first one that we see is cloud migration, and HCX by far is the easiest solution that we have seen when it comes to cloud adoption. We have seen a few customers in the region, and I'm sure you have your own customers who would be adopting, who would be embarking on the journey, or probably already on the journey of going native cloud. Again, nothing wrong with that. It's just that it takes more time and effort when we have to migrate any of the existing workloads and move them either to native AWS or native Azure or natively to any of the other clouds which are not using vSphere as the hypervisor. That refactoring, replatforming is a very painful and tedious time-consuming effort. So that's where HCX truly shines, when it can give us that hybridity of potentially vMotioning a virtual machine from on-prem to cloud. Right, so let us look at what are the components that make up this solution. So the very first component that I want to introduce to you guys is HCX Manager. Now, HCX usually works in a pair of appliances. So every appliance that you have on the source side, you will have a parallel appliance on the destination. So HCX Manager, if I were to draw a parallel, is very similar to NSX Manager. So if you're familiar with NSX Manager, the NSX Manager ties to a vCenter, and then it enables us to deploy a fleet of appliances like NSX Controller, Edge gateways, DLRs, all those things. HCX Manager is very similar in that sense, that HCX Manager will have a one-to-one connectivity with the vCenter, and it enables the framework from which we can then deploy the other appliances. So on the left, you can see that it's HCX Enterprise Manager. That is what is deployed on the source side. And on the target side, you would have HCX Cloud Manager. So this is deployed on the target side. Now, when I say target side, that target side could be a cloud provider, it could be VMC, or it could be your own data center where you have a migration or data center consolidation going on from on-prem to on-prem. In that case, both the components, the source and the destination, will be deployed by the customer themselves. So in other cases, like IBM Software or VMC, the HCX Cloud Manager is deployed by the cloud provider themselves. Right, so these are the services that HCX Manager enables us to consume. Now, again, all these would be discussed in the following slide. What I wanted to introduce to you was that HCX Manager is deployed on the source and the destination, and then there is a pairing done between the HCX Manager themselves. HCX Manager on the source is HCX Manager Enterprise Manager. HCX on the destination is HCX Cloud Manager. So there, the pairing is always between the Enterprise Manager and the Cloud Manager. We cannot tie together enterprise and enterprise. We cannot tie together cloud and cloud. So it is always the Enterprise Manager connects with the Cloud Manager, and that enables us to consume the services which are depicted at the lower half of the screen. So the very first appliance, and which is also a mandatory appliance that is deployed once the site pairing is done and the HCX managers have been deployed, is WAN interconnect. So for any migration to take place, bulk migration, this appliance is mandatory to be deployed just for the basic functionality to be made consumable to the administrator, to the customer. All the other appliances are optional. The customer may choose not to deploy them if they don't have a use case for those appliances. Now, in a nutshell, what HCX WAN interconnect does, it is again deployed in a pair. So you will have a WAN interconnect on the source. You will also have a WAN interconnect on the destination, and they will create a tunnel, a VPN tunnel between them. And all the data, when the virtual machine or the workloads are migrated over, will flow through this tunnel, and it will be, the data will be encrypted. Now, again, you could segregate the data plane and the control plane. You may want to use HCX WAN interconnect only as a control plane and offload the data plane to another network, that is fine. But in a nutshell, it provides the basic connectivity, the encryption functionality for the workloads to be migrated. The next appliance that comes and ties very closely with WAN interconnect is the WAN optimizer. The WAN optimizer works very closely with the WAN interconnect. The primary functionality that WAN optimizer provides is data deduplication, compression, and also line conditioning. So mainly these three things. Now, as we'll see in the demo as well as in the following slides, then WAN optimizer does not require any IP address. It's a VM that only communicates with the WAN interconnect. So WAN interconnect will pass the traffic to the WAN optimizer. The optimizer will do the deduplication and compression and pass the traffic back to the WAN interconnect to be sent to the target site. So these two VMs are always residing on the same host on the same data store. Now, the third appliance that I want to introduce you to is this is layer 2 extension. It was earlier referred to as L2C. The idea of layer 2 extension is very similar to the concept of Cisco OTV. The idea is to stretch a VLAN across two geographically different locations. So again, this is a pair of appliances. So you will have L2C appliance on the source and the destination, and it will form a tunnel between them, and all the virtual machine east-west traffic will flow through the tunnel as the virtual machines are migrated. So I'm going to cover some of the scenarios, including proximity routing, in the following slides. But just to give you an introduction, the layer 2 extension is very similar to Cisco OTV functionality. The idea is to stretch a virtual VLAN between two different sites. So this is what enables a virtual machine to retain its IP and MAC address when it is migrated over to the target site. There are a few caveats. I'm going to cover them during in the diagram where I will explain how the traffic routing happens. Just to introduce to you, when a virtual machine is migrated over from the source to the target, and the virtual machine resides on the VLAN that is stretched using L2C, the gateway still remains on the source if we are not using proximity routing. So any north-south traffic in and out of that specific VLAN will still need to use the gateway that is on the source side. Right, so here we see a diagram depicting proximity routing. So this is one of the concerns of a lot of customers when they do a stretch of the VLAN, and let's say it's a /24 VLAN, which means that potentially you could have over 200 virtual machines on that specific VLAN. So if you have 200 virtual machines, HCX has a limitation of migrating only 100 at a time. So let us say the customer migrates the first 100 virtual machine from the source to the destination, and the remaining 100 are still on the source side. So at this point in time, the virtual machines which are on the same VLAN will talk to each other through the tunnel, and any traffic that has to go out of the VLAN will need to use the gateway on the source side. Similarly, any traffic that has to come into the VLAN to talk to any of these 200 VMs will still need to hit the gateway on the source side. Now, the way to overcome this is something called proximity routing. Proximity routing means that the traffic routing is location aware, which means that instead of hairpinning the traffic back to the source side and then exiting from the source gateway, we will have a NSX edge that would be used as a gateway on the target side. Now, the way this is achieved is using a /32 static routes, which are injected whenever virtual machine is migrated from the source to the destination, and it is recycled. So recycled in the sense it is rebooted. So do bear in mind that for proximity routing to be effective, a virtual machine has to be restarted, and it does require the two sites to have OSPF or BGP protocols to be enabled so that they can learn the routes that are on each of the sites. Any questions so far, guys? Been blabbering for about 15 minutes. If you have any questions, just feel free to interrupt and we can discuss it. So the next thing that HCX Enterprise introduces is OS assisted migration. What this migration enables us to do is migrate workloads which are non-vSphere native. So let's say a customer has workloads which are running on KVM or Hyper-V and they would want to migrate them over to vSphere. Then in that case, the OS assisted migration option is available for them. The way that it works is there are three components to OS assisted migration. You will have a Sentinel agent, which is actually deployed on the workloads which are to be migrated. These workload would be running on either Hyper-V or KVM. So there is an agent that is deployed, and then we have the HCX gateway, Sentinel gateway appliance, which is deployed on the source side, and Sentinel data receiver appliance, which is deployed on the target side. So as you can see, again, the Sentinel appliance also exists in a pair. You have the gateway appliance on the source side and you have the data receiver on the target side. And the idea is that the agent would connect to the data receiver for the data to be passed over and the virtual machine to be migrated on the target side. The Sentinel gateway appliance works for inventory collection. So in the source vCenter, when we log in and see what are the virtual machines that are to be migrated, we can see the inventory there based on the gateway appliance. Right, so what are the migration options? So one of the things that the customers are quite interested to know is how much of the downtime are they looking at, or what are the options that they have so that they can plan their migration. Well, the first one is a no-brainer. If your VM is powered on, then it's a cold migration. It automatically defaults to a network file copy, wherein the virtual machine will, in its powered off state, will be migrated from the source to the destination. The second one is quite interesting. It's HCX vMotion. So the concept is very similar to the regular vMotion that we have in our vCenter, but this is sort of a regular vMotion on steroids. So as you know, that a regular vMotion has some restrictions. The vCenter servers have to be in the same SSO domain, and the versions of the vCenters have to be very similar. Whereas with HCX vMotion, these boundaries are overcome. So what we are able to do is we are able to do a HCX vMotion between two separate SSO domains, and the versions of the vCenter could be as varied as 5.5 to 6.7. So you can have a customer who's running the source vCenter on 5.5 with ESX 5.5 U3, and then the target could be the latest version of vSphere, which is at the moment 6.7. So you could still do a vMotion between these two very disseparate environments. One thing to bear in mind is the vMotion operation is sequential. So let's say you have 50 VMs, then the operation is sequential. It'll pick the first one and take the second one only when the first one has completed. So that could pose a bit of a challenge, because with vMotion, even though we are looking at no downtime, the whole migration window becomes very long, especially if you are dealing with larger VMs with 2 terabyte or 5 terabytes of data. So that's where there's another option called bulk migration. Now in the bulk migration, of course, the virtual machine has to be powered on. And during this time, what happens is it uses vSphere replication as a mechanism to replicate the virtual machine. And the cutover is warm, which means that during the time of the cutover, the virtual machine on the target will be powered on. It will be sort of rebooted. But the sequence that it follows is when an administrator, they have two options. Either when they're doing a bulk migration, either they can say that as soon as the data synchronization completes, the VM can cut over, or they can say that the cutover should only happen during a approved green zone. So let's say they have a migration window of 6 to 8 hours over a weekend, probably Saturday late night, Sunday early morning, and that's when it is all right for the mission critical applications to be down for a short while. In that case, what the administrators would configure is they will start with the initial synchronization, and they will then wait for that maintenance window to approach. And as the maintenance window approaches, that's when the migration will then move forward. The virtual machine on the source will be powered off, and there will be a final synchronization of the disks once the source and the destination are both confirmed to be exactly the same. At that point in time, the VM on the source will be renamed and the VM on the destination will be powered on. Now, the good thing about HCX bulk migration, your source always remain intact, which means rolling back, reverting back the changes is as simple as switching off the VM on the target and powering on the VM again on the source. So your source is still preserved. Whereas as in the case of vMotion, the source is not preserved. Now you can see that there are two boxes, and these two boxes basically talk about the two versions of HCX which are available. So we have HCX Advanced and we have HCX Enterprise. So the three options that I spoke about are available with HCX Advanced. The remaining two options are available for HCX Enterprise only. So if there is any customer who's already entitled for NSX Enterprise Plus, then they can use the same license to enable HCX Advanced, and they can use this functionality. HCX Enterprise requires a separate license. So the two features that we see at the bottom, OS assisted replication and replication assisted vMotion, are available only on HCX Enterprise. Now I already spoke a little bit about OS assisted replication. This is primarily for workloads which are non-vSphere native. Replication assisted vMotion brings together the goodness of both HCX vMotion as well as bulk migration. So what that means is the initial synchronization and copy of the disk is done using vSphere replication. So that can be done in parallel. And once that replication has been done, which means that the disk has been copied, but the virtual machine is still getting running and being executed on the source side. At that point in time, when the maintenance window approaches, the virtual machine mechanism will take over. The vSphere replication will do a handover to vMotion protocol. And from that point in time, it will use the data that has already copied as seeds and then vMotion the VM across. Now, what that means to a customer is, even though the vMotion operation will be sequential, the data that actually needs to be copied will be much smaller. So we are potentially looking at a fraction of the data that would need to be copied as part of the vMotion operation, and thus that operation will complete very, very quickly. So initially, if we are just doing HCX vMotion for a VM that is 2 terabyte or 4 terabyte, it will take a very long time. Whereas for replication assisted vMotion, we can initiate the replication of the data beforehand, and then when the vMotion mechanism takes over, there will only be a subset of data that needs to be copied and migrated over. So again, the migration is live. There is no expected downtime during replication assisted vMotion. Now these capabilities, HCX vMotion and HCX bulk migration, as well as replication assisted vMotion, there are 3 slides on this that primarily talks about what are the requirements, like what are the versions required, what are the hardware versions needed for the functionality to be used. Again, do bear in mind that it is no magic. We cannot migrate from AMD to Intel in any way. So do bear in mind those capabilities, especially when we are talking about vMotion. When we are doing bulk migration, yes, because the VM restarts, we can migrate from Intel to AMD or AMD to Intel. Right, so I'm going to jump over these slides because I would want to spend more time on the demo that we should look at. So let me spend a couple of minutes on network extension. So again, as I mentioned earlier, network extension or L2C enables us to stretch a VLAN across two sites. This is the feature of the product that enable us to retain the IP and the MAC address, and there is no changes that it needs to be done on the operating system or on the application layer because of the retention of the IP and the MAC addresses. Again, L2C is required if you're doing a vMotion, because we want to make sure that the network on the target site is available so that the virtual machine does not suffer any downtime. So just to give you a brief overview of how the traffic will flow, as you can see that there are two networks, green and blue. These two networks are stretched. Now, if there are any VMs which are residing on the target site, which is the one on the right, these VMs will still need to route their traffic through the gateway on the source site if proximity routing is not enabled. Now, proximity routing is a feature that is available on IBM software. It is also available on OVH. Even on on-prem to on-prem deployment of HCX, this feature is available. But as of today, the feature is not yet available on VMC on AWS. So when we enable proximity routing, what will happen is instead of hairpinning the traffic back to the source site, the virtual machines will be able to use the local compute gateway, NSX gateway, to route the traffic outside. So that would need BGP and OSPF protocols to be set up between the two sites. But again, do bear in mind that on VMC, this feature is still work in progress. Now, these are some of the configuration maximums. The one thing that I want to draw your attention to is the L2C can only stretch 8 VLANs per appliance. So whenever you're deploying an appliance that is for stretching of a VLAN, if there are networks more than 8, let's say you have 12 or 15 networks, in that case, you would have to deploy 2 appliances for L2C. There is a school of thought that says that why not deploy 1 appliance per VLAN? Again, that has its pros and cons. The limiting factor would be that you would have to deploy multiple appliances. The benefit of such a configuration would be that, let's say there would be a tunnel and a pair of appliances for every VLAN that you want to stretch. Let's say for some reason one of the tunnel breaks or one of the L2C appliances goes 100% CPU or crashes for some reason. In that case, your blast zone is limited to that specific network. All the other networks will still continue to function fine. Right, so that brings us to a demo. Just a pause for a few seconds if there are any questions or if there's anything that you want me to cover again. Nothing? All right, just a quick check. Are you guys able to see the screen that I'm sharing right now? It's VMC on AWS screen.
Yep, I can see it.
Awesome. So we are logged into VMC on AWS, and as you can see, there are 2 data centers that have already been deployed. We are primarily going to work on the one on the left side. So this is a brand new SDDC that has been spun up. There is no configuration from HCS perspective that has been done. So just to activate the appliance and the HCX functionality, we need to go to the add-ons, and this feature is available as an add-on. So click on Open HCX, and it will give us the option to deploy HCX. So again, since this is a cloud platform, a lot of the things that you may need to do additionally on on-prem target site are done automatically by VMC on AWS, and it'll be a similar experience for you if you look at something like SoftLayer. So we'll go to deploy HCX and do a confirmation, and it goes through pretty quickly. So we'll close, and we can see that it is deploying the HCX appliance and also registering the HCX manager with the vCenter of this data center. So at this point in time, we'll go back to our VMC on AWS. Now we would need to enable the traffic to flow into these HCX appliances. The HCX appliance on VMC will capture 2 public IP addresses. So we need to allow traffic from outside to be routed to these HCX appliances so that we can make a connection from the source vCenter and source HCX Enterprise Manager. So we'll go to Gateway Firewall and go to Management Gateway and add a new rule. Give the new rule a name, and then we'll go to the source. For the source, we'll select any in this case and save it. For the destination, it will be the 2 IP addresses, which you can see here. The grouping of those IP addresses is automatically created for us. So you can see that the group already exists. So we'll select that one and say save. And then services, usually HTTPS service is good enough. But for this case, I'm going to select all 4 of them, including ICMP, and publish the rule. So do take note of the public IP addresses that HCX captures. Again, these are masked for the purpose of this demonstration, but these are the 2 IP addresses that we need to take note of. And once this is done, we would also need to take note of the vCenter user ID as well as the password. As you would know that it's a VMC vCenter. So in this case, we'll not have access to the usual account of administrator at vsphere.local, but we will have access to this account, which is cloudadmin at vmc.local. So take note of the account, copy the password, and then the next thing that we want to make sure and validate is that the firewall rules that we have created, those are actually working. So go back to the HCX manager on the destination and click open HCX. And if this window appears, that means that our firewall rules are functional and we are able to access the HCX manager. Log into the HCX manager at this point in time, and you can see that there are a number of VMs which have been already deployed and the connection to the vCenter has been made. These are the 2 direct connect networks, the 2 public IP addresses that we noted in the previous screen. So at this point in time, we are almost ready to go to the source site and configure it. So the OVF that we download to be deployed on the source side is actually available here. So we click on download the OVF, request a download link, and it will then start downloading the OVF file. Now there's one more thing that we need to do before we proceed, and that is to capture the, actually 2 more things, not one. One is to take note of the HCX cloud URL, and the next one is to take the activation key with which the source HCX Enterprise Manager will be activated. So take note of the URL for the destination HCX. You can see that we are populating it on a notepad. We have taken note of the 2 IP addresses. We have taken note of the cloud URL. And the next thing that we want to do is to take note of the activation key. So we'll go here. Oh, it's sort of blocking my window at the top. Give me a second. Let me hide it. Okay, that should work. So we go to activation keys and create an activation key. It'll give us, do a confirm, and it'll give us an activation key with which we can activate the HCX Enterprise Manager on the source side. So these are the things that we have taken note of while configuring the HCX solution on VMC on AWS. So similar things you would want to take note of if you are configuring an on-prem target site for HCX. Right, so at this point in time, we'll jump to our source vCenter. So this is your on-prem data center vCenter. The first thing we need to do is just deploy the HCX OVA file that we downloaded earlier. So this is a very straightforward process. I'm going to go through as quickly as possible in the interest of time. It's a standard deployment of the OVF, which we probably would have done a few hundred times. So accept the EULA, say next, and select the data store where you want the VM to reside on. Now this is a bit important, so I'll spend a few seconds here. HCX Enterprise Manager appliance should reside on a management network. So if you have a network, a specific VLAN on which you have your vCenter deployed, you have your ESX management VMKs deployed, in that network, this appliance should be deployed on. So select the management network, give it the details that it requires, like the admin password. So HCX Manager, when it is deployed, will can also be managed from the management console, which is on port 9443. And this is the ID that is used to access that management console. So the user ID would be admin, and the password is the one that we specify here. Root password is again for troubleshooting purposes primarily. If you want to do a health check on the appliance by logging on to the shell, then root password would be needed. Give it an IP address that you want the appliance to take, subnet mask, and then the gateway. Generic configuration like DNS and NTP server that would be needed for any other VM. Once that is done, we'll proceed by clicking next. Again, you can review it and then we'll click finish. So at this point in time, the HCX Enterprise Manager will be deployed. The next thing we need to do is to power it on. And once it is powered on, we would want to make a connection to the management console on port 9443. So key in the IP address that we had specified during the deployment of the OVF and use port 9443 to make a connection to the management console. Log in with the admin ID. And the very first thing that it would ask you is, what is the activation key? And now again, something that I probably did not mention earlier, both the target and the source would need connectivity to two URLs. So there are two URLs that HCX Manager, both the Cloud Manager and the Enterprise Manager, needs access to. The very first one, you can see it on your screen, connect.hcx.vmware.com. This is needed for activation and also to see if there are any updates which are available. The second one is hybridity-depot.vmware.com. That URL is needed to download the updates. So the updates which are published will be made available through this URL, and the actual binaries that we want to download to update the solution will be available on the hybridity-depot URL. So do bear in mind that those two URLs are required, and they are not only required during activation, they are required during the course of the solution's lifetime. So the license key we had copied earlier. So this is the license key that we captured from the target site. So let's copy it and key in here. And let's try and activate. Key in the name of the place where this solution is tied to. In this case, that will be Austin. And we'll say continue. And you can give it a system name. So if you would want to name the appliance as per your corporate naming conventions, you can change the name here, say continue, and say yes, continue. With that, you would be asked to key in or pair the HCX Manager with your source vCenter. So again, as I mentioned earlier, there is always a one-to-one pairing between the HCX Manager and the vCenter. So since we are configuring on the source side, the source vCenter is required. So key in the IP address of the source vCenter. and the user ID and password and say continue. And if you have an external PSC, you might need to key in there. If it's an embedded, then the same URL of your vCenter would be great. Now, I would just want to point out that there is, if you're doing a deployment on your target site, which is owned by you, not a cloud offering like VMC. So in that case, the deployment is pretty similar. One thing that would be additionally asked is the connectivity to NSX manager. So on the target side, NSX is a must. It is needed for the solution to be deployed. So the registration and the process of deploying the HCX manager is very similar. The only additional option that you would get on the target side is to register the appliance with the NSX manager in addition to the vCenter. So we'll go ahead and restart the appliance, and once it restarts, it'll come back online. And a few things that you would want to check is this green button. This green button shows that the HCX manager is communicating fine with the source vCenter. Again, NSX is blank because it's not mandatory. On the target side, it would be mandatory, and you would be able to see the connectivity between HCX manager with NSX manager. Right, so at this point in time, if we go into the menu, we are able to see the HCX icon, and we can go there and then start configuring the source and the destination sites together. Now, if we go to interconnect, as you can see that there's nothing configured at the moment. We saw earlier that there is no VMs that are in migration. There's nothing that is scheduled. There is no network extension that is deployed. So it's a plain vanilla deployment yet. What we need to do is the very first thing is to pair the site. So we'll go into multi-site service mesh, and we'll go to site pairs and make a connection between HCX Enterprise Manager on the source site, which is where we are at the moment, and connect it with the HCX Cloud Manager on the destination site, which we configured earlier on VMC on AWS. So I want to make that connection and do the site pairing. Again, this is the same URL that we copied earlier. So this is the URL that we had copied a few minutes back. We are going to put it here, and the username for the cloud admin account. Key in the password as well. Once done, we'll say connect. And as you can see that the connection is successful. So from a high level, what we've done is we have deployed HCX Manager on the source and the destination side, and then we have paired the sites together. So pairing of the site is the second step, and the third step is actually deploying the appliances which make the solution functional. So the 3-4 appliances that I had mentioned earlier, like WAN interconnect, WAN optimizer, layer 2 extension, all these appliances are to be deployed on the third step. Now the way to deploy has changed over time. Initially, it would be a screen where you would deploy HCX components by choosing which component to deploy. Now it has taken the shape of a multi-site service mesh. So we have to declare what network these fleet appliances should land on and what IP addresses it should use. And then on the compute profile, we'll declare which cluster, which host, which data center these appliances will need to land on when they are spun up by the solution automatically. So we'll select and create a couple of network profiles. And in this one, we'll select the distributed port group and select the management network for the appliances to land on. This is a network profile, and we'll associate the network profile with a type of appliance later. So what we are telling or declaring in this screen is, on this network, use these IP addresses with these details. So this should be the gateway, this should be the subnet mask, and what should be the DNS and the DNS suffix. So once done, we'll say okay. So depending on the type of traffic that we have on on the solution. So one of the types of traffic is management traffic. Another one is vMotion traffic. Another one is vSphere replication traffic. So all these can be segregated and can be defined here. So a very typical example is vMotion traffic. A lot of our customers have a non-routed subnet on which vMotion traffic flows. So we need to specify which network is to be used for vMotion traffic, and we need to provide access to our fleet appliances to that specific network segment. Right, so key in the details, the IP that these appliances should use, and then subsequently what should be the gateway. And again, as you would see, the gateway is not mandatory. Say create. And at this point in time, we'll move to compute profiles. So compute profiles would help us identify where these fleet appliances should land on. What are the clusters? What are the data stores on which they should reside on? So give it a name and say continue. And in here, we can select which appliances we want to be deployed. So as I mentioned earlier, WAN interconnect is a mandatory appliance. It has to be selected. All the other ones are optional. For some reason, let's say the customer does not have a use case for a vMotion. In that case, we can unselect it. Maybe the customer only has a use case for bulk migration. They want to migrate a larger number of VMs with a short span of application downtime. That's fair enough. Then they can choose not to use vMotion as an appliance that needs to be deployed. So we can choose the ones that you want and say next. And this one will specify which cluster these VMs will be hosted on. So again, there's no one-to-one mapping between the cluster and the appliances. You can have a cluster like a management cluster where all these appliances will reside on, but they can serve all the remaining clusters that you have on the same vCenter. Alternatively, you can create one multi-site service mesh profile for each of your cluster. Let's say you have clusters which are very isolated from each other in the sense that the cluster has its own dedicated data centers, dedicated data stores. It has its own dedicated VLANs for each type of traffic. In that case, you may want to create a different service mesh for each of those clusters. Otherwise, if your clusters do share the VLANs, then you can use one cluster and it can serve the remaining of the clusters. Say continue and select the resource pool if you have resource pool. In this case, we do have, so we are going to select that. Select the data store where you want these fleet VMs to land and say continue. And this is where we'll specify the management network profile. Now, what we are doing is we are telling the appliances which will be deployed that for this type of traffic, use this network. That specific network could be one of the VLANs that we want to choose, and it would be configured on one of the distributed port groups. So select the VLAN, the management traffic would route through it. By management traffic, we mean that the the HCX Enterprise Manager will communicate with vCenter and ESX management network through this network. So select the management network and then say continue. And secondly, select the uplink network profile. So by uplink network, we mean what would be the VLAN on which the two appliances, the source and the destination, would talk to each other. So this is like a transport layer on which these two appliances through a routed network will be available. So in our case, it is the management network itself. We'll say continue. And then this is what we configured earlier, the vMotion network. So I had explained what the use of vMotion network. If you have any network that is used by the customer that is non-routed for vMotion, you can configure it and use it. Alternatively, if you want to create a new network profile, you can do it through here as well. We'll say continue. And this is for customers who are probably already using vSphere application and they have configured their environment for dedicated networks for vSphere application. In that case, you can use the vSphere network, vSphere replication network for replication of the VM. So all the data that will be flowing from source to the destination will use this network. A lot of customers would just let the management network be used for vSphere application as well. So that is also something that we see in production environments. Now, this is what we see for network extension. So again, bear in mind that the L2C appliances that we deployed are bound by distributed switches. So let's say you have two distributed switches with multiple port groups inside of it. You would need to deploy two layer 2 extension appliances, and each appliance can serve and extend a maximum of 8 networks. So let's say you have 15 networks on one distributed switch, then we would need to deploy two layer 2 L2C appliances on that specific distributed switch to serve the total of 15. So one will serve 8, the other one would serve 5. Right, so we'll enable this L2C on this VDS. Say continue. At this point in time, we'll get a screen that will tell us what traffic would be flowing and what are the IP address that will be used. Close it, continue, and finish. Now, at this point in time, we are pretty much ready to deploy the service mesh. We had declared the network. We have declared the compute profiles. Let's create a service mesh and go through the deployment of the appliances in this step. So select the source and the destination. In this case, we have only one source and one destination. You could potentially have multiple destinations connected to the same source. Say continue. Select the compute profile that we had already created. Select the compute profile for the destination. Say continue. Again, we have the option of pick and choose which appliance we want. So you can deselect the ones that you don't need and select the uplink network. If you want to override any option, you can do it in the service mesh itself. In this case, we'll use the external network. Say continue, and then configure the network extension appliance. So we had configured the VDS earlier. We are fine with this. Let's say for some reason you would want to limit the number of L2Cs that can be deployed, you can limit here. So here we have set it up as 1. If you want to change it to 2 or maybe greater, you can set it up here. Say continue. This one time we are almost ready. Give it a name, and once done, we'll click finish and proceed with the deployment. Right, so once we click on finish, the deployment of the fleet appliances would start on both the source and the destination together. So we'll just explain the tasks and we'll see the different appliances being deployed. Herein, we should be able to see the appliances being deployed. You can see that there is nothing under the tunnel status. There is nothing under the current version because these are still being deployed. And if we expand here, we should be able to see various appliances getting deployed. So at this point in time, I think we should be almost done with the deployment. As you can see, the status is up. Let me bring you back to the screen. Yeah, the tunnel status is up. So this is something that we would obviously want to check once the appliances have been deployed, so that we make sure that the connectivity between the two pairs has been successfully set up. That brings us to the end of the demo. And again, guys, apologies because of the hiccup at the beginning. We are stretching out a bit. We should be done in another 5 minutes. I wanted to draw your attention to how this solution works actually in the field. So I wanted to share with the migration that one of our largest customers did in the APJ region. They had a project of data center evacuation wherein they were looking at roughly 2,500 VMs to be migrated. Now, these are the key requirements that the customer had even before they had heard of the HCX as a solution. Now, VMware had not proposed it yet, and I'm talking about something that happened roughly about 1.5 years back. And the customer wanted network portability, the ability to retain MAC address and IP address, consistent operations, meaning that all the upstream and downstream dependency mapping of the virtual machine should not be done. The migration should be as seamless as possible. Orchestration, the ability to execute the migration by the system itself. The administrators would only be required to declare how they want the migration to go and at what time do they want the migration to go, and with minimum application downtime. So the customer looked at primarily three solutions. They did explore vSphere Converter, vSphere Replication. These were some things that they were very familiar with, but then obviously there was no ability for these solutions to stretch the network and the ability to retain MAC and IP addresses. They also explored one of the enterprise grade migration tools that is very common in financial and telco sector, but that again had its limitation. One of the outliers was a backup solution. So they were also looking at the option to potentially take a backup of the VM and restore it on the target side. But again, it was not very efficient. So I'm going to skip this slide. It basically a mapping to the requirement that the customer provided, but I want to walk you and draw your attention to how the migration actually spanned out. So in total, it was roughly about over a year's effort. So in Q2 is when we proposed this solution to the customer. That's when PSO got involved, and there was a proof of concept done for this customer. And once the key requirements were satisfied, the solution was found to be feasible. The customer then started preparing for this solution and started doing a knowledge transfer of preparing the operations guys on how the solution is to be deployed and consumed. Then this was the first time that this customer was using HCX. So they had to also do a bit of internal socializing. They have mission critical applications that are doing real-time trading. So they wanted to make sure that the application guys are aware as to what they should expect from this solution. So that took about a couple of months, and then eventually we drew to a time of roughly about January. And if you look closely at the graph that is at the bottom of the screen, you can see that there is a very linear line that goes from left to right. Now, this is the line which is a projection when the customer has not even heard of HCX solution. So they were looking at a time frame of roughly about 15 to 18 months. And that's how they thought that these 2,500 VMs will be migrated across. And this was based on their prior experience of data center evacuation, data center consolidation, those kind of projects. So the two lines that you see, the yellow and the green one, are the ones that actually the migration, how it spanned out. So as you can see, the yellow one is the one that when they had done the HCX solutions proof of concept, when they had confirmed that HCX would be the solution to be used for this migration, they charted out this yellow line showing week by week how many VMs they will be migrated. And green is the one that they actually ended up migrating. So yellow is the projection, green is the actual. So again, very close to each other. The only deviation you see there is because of the decommissioning of some of the VMs. So during those 6 months, roughly about 80 odd VMs got decommissioned. That's why there is a bit of a deviation. So one comment that we really cherish from this customer is a migration of this magnitude would have taken them roughly 1.5 years with significant more time and effort from both application and infra teams had it not been for HCX solution. So there is very clear savings in terms of the migration effort, in terms of the reduction in the time frame that the customer used to migrate their workloads and evacuate the data center. So one more slide. It wasn't really just a win situation for the customer. It is also a win-win situation for us as VMware. The customer requested a few feature requests, which are some of them are already embedded in the product, some of them are being worked on. One of the things was the ability to migrate 200 VMs. By default, the product limitation is 100. The customer wanted 200 and they were happy to do a risk sign off. So it was increased to 200 and it has worked fine. The next one is the ability to name the fleet appliances so that the appliance will not have random names, but names according to their corporate naming convention. The third one is the ability for the L2C appliances to be deployed in a HA pair. So in case there is an outage, the HA appliance will kick in and will restore connectivity very, very quickly. The last one is the ability to restart migration. So this customer was using virtual machines which were very large, like 2 terabytes or 4 terabytes or 5 terabytes in size. So they wanted to have the ability to restart the migration from the point that it fails. So these are the feature requests. A lot of this is already embedded in the product. Some of them are being worked on. So that was my last slide. And I am happy to take any questions if there are. If there is anything on the chat window, I would review it and I will come back to you. So with that, Steve, I'll pass the time back to you.
Awesome. Yeah, thank you for that. Anybody on the line, if you've got questions, feel free to unmute yourself and ask away. Otherwise, we'll wrap it up here. All right. I guess that's no questions. So thanks for your time, Rahul. Any last thoughts?
Well, there's a question on the chat. So that is from Alonso. I am going to reply to that on a one-to-one. And if you want to forward it along with the session recording, I'm happy to share that as well. So Steve, thank you for the opportunity. Much appreciated. It is my pleasure to be part of TAM Labs.
Awesome. Thanks, everybody. Have a good rest of your week.
Thank you. Bye-bye.